Okay, so instruction fetch. Okay, the 5 stages of instruction execution. I'll repeat again because I will record for those who didn't follow us. Okay, as I said, this is analogy of how instruction will be executed using the 5 stages. Okay, this is single processing and this is in parallel. So what happened in here? Okay, we start with instruction fetch, instruction decode, okay, execution, memory, and write back. Okay, 5 stages in here. But doesn't mean that all the instructions, okay, need to use all these 5 stages. For example, if I want to add or if I want to load into the memory, okay, so in this case we don't need to write back into register file. Okay, so only use 1 2 3 4. If we want to add, okay, make add operation, okay, so the add operation doesn't need, okay, to use, okay, the memory. Okay, if we are adding, for example, add x1, x2, x3. So what happened in here? Okay, we are adding x3 to x1 to x2, sorry, and the result in x1. So in this case, we don't need, okay, to use memory. Okay, so see, it depends on the instruction we're working on. Okay, so this is the first idea I want to deliver in this session, is the 5 stages of executing an instruction. Not all instructions need to, okay, to apply all the 5 stages. As you can see an example in here. Add instruction, okay, doesn't need to use a memory. Load, okay, use memory without write back. Okay, so this is the first idea for today. So the second idea, because we are working now in parallel, okay, in some sort of writing machine code, okay, for example, first instruction produce, okay, or store the result into one register, and this register must be, okay, or need to be used in another instruction. So say, for example, the first instruction is not finished yet, okay, it means the output of the first instruction is not ready yet, and the second instruction want to use this output. So what happened in this case? Did you get the idea what I mean? We have 2 instructions, okay, calculating some registers. Second instruction need to use the output of the first instruction, but the first instruction is not finished yet. So in this case, we have what we call, okay, the hazard. Okay, say for example in these 2 instructions, the first instruction, okay, is writing, okay, the result of x0 plus x1. It's like this, x19, it's equal to x0 plus x1, simply like that. Okay, and x2 is the difference between x19 and x3 into writing into x2. See the 5 stages in here. The first instruction, this is 1 and this is 2. This is 1, okay, and this is 2. These are the 5 stages: fetch, decode, execute, memory, write back. Okay, the second one, fetch, decode, execute, memory, write back. So what if this one in here, okay, need to execute, all right, the value of x19, okay, need to be sent to here. All right, if we want to wait until write back, okay, this instruction, okay, to get the value of x19, okay, it needs to go to write back into register, okay, write back, then put in x19 the values. Okay, however, okay, the second instruction before executing need this value to execute the subtraction. Is that clear? Yes? Is it clear what I'm saying? Can you hear me?
Yes, Doctor.
Okay.
Yes, doctor.
Say, for example, I need to move a value. Okay. So in this case, so when we execute, when the instruction is executed in here at the third stage, okay, this first, second, third stage, when the instruction is executed, it means the value of x19, okay, is ready, okay, but it's not written back, okay, following this, following the same the stages, the order of the stages. So what happened in here? The value will be sent automatically because after execution, the value is ready. Okay, is ready in here. So it will be sent immediately to the second instruction before executing. Okay, then execute it in here and find the answer for it. Okay, so this thing we call it hazard. If the value we needed it's not calculated yet, how we solve it? We solve it using, okay, using what we call, okay, forwarding, okay, or bypassing, okay, bypassing. So by after execution, we pass, okay, the value, okay, to the second instruction, okay, then will be executed. See, okay, see for example in here, x1 is ready, okay? Then will be sent it to here. So x1 is there now, okay. Then we subtract them and write back. In here we write back into x1, and in here we write back into x4. Okay. So this is the solution to solve, okay, what we call
دكتور
data hazards. Hey, yes.
انه كيف بيجوا مثلا questions على هيك قصص؟
مثل هون if I ask you for example to find, okay, is there a hazard in here, how do we solve it? You may for example put these 5 stages. Okay, مثل هون أنا كيف أنا I'll show you. Okay, okay, كيف هون في عندنا 5 stages. Okay, انت بتحط الانستراكشن. Okay, first in 1 2 3. Okay, بس انت what do you need to know after execution. Okay, بعد ما نعمل احنا execution للinstruction كل الفاليوز بيكونوا صاروا معنا. Okay, so من هون after this step we can send them to any other instruction before execution. احنا امتى بتستفاد من الانستراكشن الثانيه؟ اوكي، لما بنبعث لها الفاليو اللي بدها اياه before شو؟ before execution.
okay.
لكن نحن okay, the value that we needed must be first executed, okay, then we send it again to another instructions that need this value. like هون في عندي هذه instruction need this value, so it must be sent before what? Before execution. Okay,
execution.
all right. طب هيدي
Thank you.
Okay, this is the second idea for today. هلا في so one more, let me find it. I have one more thing for you, an example of using, okay, R type or R format. Where is it? I think this is before. Okay, this one. If you remember, in chapter 2, and I added this slide to chapter 4. So this slide is from chapter 2. So in chapter 2, we have only these things in here. Okay, only this part, talking about the R format instruction. Okay, I give you in this part, and I add to this slide an example in here. Okay, of an instruction. Okay, this is the program counter, and this is the instruction. Just quick recall about R type. Okay, if you remember, we have 32 bits in here. Okay, in R type, we have 32 bits. Okay, to run an operation or an instruction. Okay, the first in here, if we start from the most right in here, the first 5 bits, okay, are the destination register. Okay, destination register. Rn, okay, this is the destination first register or operand. Yeah, operand. Second operand or register. Okay, shift amount, and opcode is what is the operation. Okay, then so I just want to know to just quick recall, this is the destination, like in here, for example, in this instruction, add x2, okay, add x2 to x2, then write into where x1. Is that right? So it means x2 is Rn, x3 Rm, and x1 R D. Okay, add is the opcode. Is that clear for now? I just to try to remind you, okay, about the R type instruction or R format. Okay, so the destination is written on 5 bits. The first register 5 bits, shift amount 6 bits, the second register or the second operand 5 bits, and 11 bits for the operation. Okay, so in this example, this is the instruction in ARM ARM assembly. Put them in machine code, it means put them in bits, okay, either 0 or 1. So this is the 5 bits for the destination. Okay, 5 bits for the first register, 6 bits, 5 bits, 5 bits, 6 bits, second register, 5 bits, and 11 bits. Okay, so we have in total 32 bits. So what I'm trying to do with this example is to show you the data path, okay, using this diagram for R-type instruction. So the instruction in here is to add x1, x2, x3. So we are adding in here. Okay. So what is if we start the program from here, program counter. So what is the address of the instruction? Okay, what is the address in here? So what is the decimal of this value? 0043. It's 12. Is that right? This one 12. We start the program counter from here. As we said, the program counter must be incremented by
4.
4. So we add 4 in here. So it must go there, there, 3. Add 4. So it's let me see. Sorry. It's 1100. It's 1100. Means it's 12. Is that right? 1100, 12. We incremented by 4 should be equal to 16. Okay.
بس
So here should be 1 0 0 0 0. Okay. Next step, we read the instruction from here. Then we go out. Okay, we must divide the instruction into the add. Sorry. Okay, let me work on this one. Let me work on this one. Okay. We start from here. Read. Okay, the instruction is add. So in add operation, so actually what we are doing, we're reading 2 registers. Is that right? So what are the registers must be read? What are the registers to be read? Okay. What we want to do is to read x2 is from the register file and read the value of x3. Okay, we are reading and reading. Then what? Writing into x1. Is that right? Yes.
Yes, doctor.
It's very easy. It's not too complicated. When we are trying to add, it means you have to read the value of x2 and read the value of x3, do the summation and write it back into x1. It's very easy. Let me go in here. So we have to read x2. Okay. x2 is the first register. Is that right? X2 is the first registers. So this is the number of bits in here are from 0 to 4, 5 to 9. So the first register is 5 to 9. 5 to 9. Okay? First register. So this is the first register. Okay? So we read the first register at what address? 1 0. Okay, 1 0. So this is the referred first register. Okay, so this is
positive address.
This is x2. Okay. Sorry.
الأدرس بس ما كيف عرفنا؟
From the given in here. This is the address. So you look. This is the first register. Okay, of the operation of the instruction. The first register. The first registers, if you look, we have first 5 bits numbered from 0 to 4, 5 to 9. Okay, so the first register is 5 to 9. So you look at it. Where is 5 to 9? 5 to 9 is here. Okay, that means we go to the 5 to 9. This is the first register. What is the address for it? It's written in here. It's 00010. Okay. If you want, I didn't put the zeros. It's like this. Okay.
Okay.
So now let me go to the second register, RM. Okay. RM, the second register, which is this one, which is X3. X3 okay, it's from, let me see, it's from 16 to 20. Okay, because we have 0 to 4, 5 to 9, 15, okay, 16 to 20. Okay, it should be in here. So, sorry. Okay, so this is the second register. What is the address for it? 11. 11. Okay, so this is X3. So the output, okay, now we read both of them. And the operation code, okay, should go to the control in here. So what is the operation code? If you remember, when I give you the buses, okay, we have data bus and address bus and the control bus. Is that right?
Yes.
So because we have in here two registers, so what is the operation gonna do here? We have to perform is the addition. Is that right? So we have to tell the control. So what's going on? Okay. So we write the address of the opcode, which is add these bits in here, 100. So let me just put them. I'm not gonna write 100, 1011, 0, 000. Okay. So this is the operation. Okay. Is that right for now?
Yes.
Okay. Let me. The first register in here. Okay, telling us what. So at this address for the first register. Okay. So this is the address for X2. So what is the value of X2? It's 0, 1, 1, 0. So the value in here must be sent to the ALU, the arithmetic logic unit. Okay, it's 1 0 1 1 0 1 1 0. Okay, and what is the value of the second register, X3? So actually we are doing the summation of X2 plus X3. 0 1 1 0 1 1 0. It's equal to what in decimal? 4 plus 2 6. Is that right? This one 6, and this one 1 plus 2 3 plus 4 7. Okay. So the value in here sent is 111 110. So the arithmetic logic unit will perform what? The summation. Okay. So the control in here tell this small control in here to perform addition, okay, of these two values. 0, 1, 1, 0 plus 1. This is a triple, I think it's triple 1. Let me put it triple 1, 1, 2, 3, 0. Okay. So what is the summation of these two values? Is equal to 6 plus 7, 13. Okay.
Okay, doctor.
13 is in binary is 1.
1101.
Is that right?
Yes.
This is 8, 4, 12. Okay. So 1, 1, 0, 1. So the output in here is 1, 1, 0. When we are adding, okay, two registers and write back into the first or the destination register, do we need to use the memory?
No.
So there is no need for the memory in here. Okay. So we just get the answer. Okay, to get the answer in here and go there. So the answer is, as we said, 1, 1, 0, 1, which is 13. So let me just put this one is equal to 6, and this value is equal to 7. Okay, the summation is 13. Will be sent where to? Okay, so to this stage, which is the write back stage. Okay, then go back to the register file. Okay, and write into the X1 register. Okay, is that clear?
Yes, doctor.
It's very easy. It's not at the first stage. Okay, we find the instruction. Okay, then go to the register file. Depends on the format. Just you have to follow the format. Okay, R type 5 bits 0 to 4, 5 to 9. Okay, 5 to 9, 10 to 15. Okay, 16 to 20. Okay, and 21 to 31.
2, 1.
Okay, so that's very easy. So this is the destination. Okay, so in here is the 04 is the destination. We go to here. Okay, so write data into the destination, which is X1. Okay,
Good.
Yes.
Can you give an example on load or store instruction?
Load, same thing, but with load it depends on. So I have an example, but I think I don't have time, but I will send it to you. What you have to do with load, so instead of writing back, so we have to continue, go immediately from here, take the value and write it where? Into the memory. Without there's no write back, so we don't need all this thing in here. Okay, so the only thing you have to do, let me just give you, so when you understand the concept of the data path using the 5 stages, because the only thing you have to do, first of all, you have to know, so what is the format? For example, R type, okay, divided into the number of the bits, know which one is the destination first and second registers, okay, then follow them on the diagram in here to trace it. Okay, so to trace it is only as I work it in here, like 5 to 9, okay, is the first register. Okay, 16 to 20 second register, 0 to 4 destination, 21 to 31, okay, opcode. Okay, that's the only thing you have to do. All right,
دكتور عندي سؤال.
and I haven't finished yet, but let me, that's one thing. and all other things in here must be equal to zeros. Do we use a branch in here? Do we use a branch?
No.
It's 0. Okay. Do we read from the memory? It's 0.
No.
Do we, okay, it's memory to registers, also 0. Okay, arithmetic logic unit, yes, it's 1. Okay, do we write into the memory? No. Okay, 0. Okay, 1. Do we write into register? Yes.
Yes.
It's 1. Okay. So that's the only thing in here. Do we have a so in here? So this one we don't need. So this one is 0. Okay. This one, don't worry about this. Sorry. Okay. 0. So this one is AND. So since the value is in here 0, whatever the value in here, so the output is 0.
Then 0.
Okay. So now we continue from here to do the second instruction at address 16. Okay. This is the binary decimal 16. Okay. It's not too difficult. It's very easy if you understand the concept, okay, for it, and the relation between the number of bits in here and the number of bits in there, okay, where to read. So you have at the beginning, just you have one thing you have to do is to decide. So what we're gonna do with this operation, adding, okay, it means we are reading 2 registers and write back into another register, another register. It means there is no, okay, there is no memory, okay, access using, okay, with this operation. If we were working with load, okay, with load, it means we have to use the memory without write back. So what are the stages on? Let me show you the stages. Okay. We divide the stages. It should be there. Okay, these are the stages. This is the first part. Okay, we are looking for, okay, for the instruction, okay, using the program counter. At the second stage, from the register file, okay, we read, okay, and okay, write into registers. The execution, we get the output, okay, as we see the output of the 2 registers equal to 13. We make the summation for them. At the memory, if there is load or store, it means we have to use the memory, load or store, okay. If not, okay, we use the write back. So this is stage 1, stage 2, stage 3, stage 4, stage 5. Okay, do all the instructions need, okay, to go through the 5 stages? Yes or no?
No.
No, it's not necessary. And as an example, the add operation doesn't need to go into the memory. Okay, this is an example on it. So we have less than 1 minute. I hope I delivered, okay, the ideas for this session. And if you have any question on it, please let me know. So we have less than 1 minute, probably. I will. This session is recorded. I will upload it also and send you the link for it. Okay. Is it clear for you how it works?
Yes,
All you need to
Doctor,
have
can you send an example on load?
on load. I will send you something, an example.
Okay, thank you.
Okay, but if you understand the concept, you shouldn't find any difficulty with other instructions. Okay.